all that. So I am working on that. And I guess that's all I have to begin with. So I'm going to let Gerald share his screen and turn it over to him.
Thank you, Charlene. Hopefully, there we go. I have to hit the share button. Hopefully, is that, did that display properly? Hopefully. Okay, very good. All right, thank you. Thanks everyone for your attention today. I will say Charlene's suggestion, I don't do chat things very well, so let's just make this real informal. If you have a question, please just feel free to step in and ask the question. This is a little bit of an informal presentation. It's not highly technical. It's really more about a broader picture than you tend to get into with the more detailed things. But what we're going to talk about today is how you manage your data, and are you following the best practices associated with managing your data. So let's see if I can do, oh wait, sorry. There we go. Okay. So at least many, maybe most of the projects that you undertake related to stormwater involve collecting data of some sort. These data are often very expensive to collect, or at least moderately expensive to collect. So they become a resource, and they're just like any other physical resource. And oftentimes these are extremely valuable to the analysis and execution of successful analysis and execution of your project. So the question, what we want to talk about today is, are you following the best practices to ensure that you are managing your data properly? So we're going to kick around some different ideas and things, and I'm going to talk about best practices as we go. So let's start at the top, okay? Benjamin Franklin is cited as saying this quote you see: if you fail to plan, you are planning to fail. So we'll start at the top with data management planning. What that means is you need to have a plan for how to manage your data before you actually start collecting it. Ideally, I hope everyone does that, because that is actually the first best practice that we always highlight for everybody. The data management plan needs to have several key elements. You need to identify the types of data and actually the specific data that you're going to collect. You want to define the roles that are going to be associated with that. You want to assign specific people to execute those roles. It can be the same person to do multiple things, but you need to at least think through the process in order to get that down on paper. And then you also want to document the objectives, the quality objectives for your data, and how you're going to measure those. Now, a lot of people will say, well, I've got to do a data management plan, and they tend to think of it as a huge volume or something. That's not necessarily always true. The data management plan itself is going to reflect the complexity and the volume of the data that you're going to be collecting. So you don't think you have to be overwhelmed and generate a 120-page document that outlines your data management plan. Although if depending on the complexity and size of your project, that may be necessary, but in most cases it's not. I have seen data management plans that I think are complete and effective that are no more than just a page or two. It just depends on it, and we're going to explore that idea here over the next little bit. But the important part of this is that the exercise of generating a data management plan forces you to think through the process ahead of time. That way you're just not going out there and collecting data and throwing it into something and saying, okay, we've collected the data, now let's do some analysis. It helps you to formulate a plan, formulate the plan in your head so you can get it down on paper, and helps you to understand exactly the objectives and why you're collecting the data, which is first and foremost one of the most critical steps. Okay, so there are, right away we can say there are some best practices associated with the data management plan. First of all, always create a data management plan. That's first and foremost. You need to think it through before you do anything. But you can scale the plan according to your specific requirements. It doesn't have to be huge. It can be a small document, but do go through the process of identifying those key elements we talked about and documenting them, getting them down on paper. And then the last bullet there needs a little bit of explanation. It says avoid daisy chains as much as possible. Daisy chains it happens if you have one document that refers to another document that refers to a third document and everything. You want to try to keep this in as concise as possible and in one place if possible, because you're going to want to refer to that as over time as you go. Okay. All right. So let's think about now what goes into planning for and collecting the data. Well, first of all, size does matter. Okay. And by that, what we mean by that is that the volume of data that you're going to be collecting will affect how you go about not only how you collect it and what you do to house the data, but the platform in which you're storing your data. That's a critical factor as you move forward. Okay. Typically, the more data you have, the more robust will be your requirements for a data management solution. And we'll talk a little bit more about what constitutes a data management solution in just a second. A lot of people, unfortunately, I have to say, from my perspective, it's unfortunate. A lot of people will just throw the data into Excel and say, we're managing the data. Okay. Now, Excel can be an effective and acceptable data management solution, but I would argue that it's in many cases, it's inappropriately used because the volume of data, the size of the data, all that sort of thing will come back to haunt you if you try to manage it with Excel, because Excel is just not the appropriate tool for managing large volumes of data. So if Excel is not the appropriate tool, then you have to be ready to step outside your comfort zone and maybe become familiar with something else. So in thinking about how you're going to house the data, you need to think about how it all fits together. How does it work? How does your data work? And that gets into the second factor that we want to consider, which is data complexity. Okay. When you start thinking about collecting data, a lot of people will start by just thinking, okay, I need to collect this data to meet this report. These are data elements that are required in my report, so I've got to collect those data. I would encourage you to take a step back from that and think instead about your business model first, rather than just starting to identify data you need to grab. But by business model, I mean, that's an understanding of what you're doing, what the focus of your project, your organization, whatever is, and what are you doing, what are the business decisions and factors that drive what you do. Once you've identified those elements, you start to see how the data fits into that framework, and you model your data, you create your data model to fit your business model and not vice versa. Okay. Data model always should adequately support facility operations and decision making, but don't let the report drive your data model. That's something that happens a lot, but those things will affect not only how you construct your data model, but also the decisions you make about the platform that's appropriate for housing your data. Okay. There are other factors that go into deciding what methodology, what software, what type of system do you want to employ to manage your data. Some of these other factors include availability, data access and availability. Are there how many people need access to the data? Are all these people within your organization, or are there regulators outside your organization that need access to your data or will benefit from accessing your data? How rapidly do the data need to be made available to these users? And if there are multiple people using the data, what levels of security do you need to implement on that? Okay. These things also affect how you look at the people within your organization that are going to be involved with the data collection. Do you want to assign one person to be the manager of the overall process? Are you going to have a separate validation activity? In other words, are you going to have one group or one person or one group of people entering data and have someone else be responsible for reviewing and validating the data? What are the experiences and capabilities of your various staff members? You might find that you have somebody on your staff who really understands, who maybe is very good with Excel, and so and maybe Excel is an appropriate way to manage your data. If you determine that, that's fine. That's something to consider. You might want to get them involved, even if they're not directly involved with your specific function within the organization. And then lastly, of course, how are you going to support this? If you know, and that's frankly, that's one of the reasons that a lot of data ends up in Excel, is because support for Excel is pretty widespread because a lot of people know about Excel. Some of the more robust ways in which we manage data, you may not have the internal support that you think you need in order to do that. So based on all those factors, we can identify some best practices related to identifying the platform on which your data, that you're going to use to house your data, okay? Again, go back to understanding both the business model first and the data model that's built on top of that. The data model, I emphasize that all the time, the data model must follow the business model and not just be a random collection of things that you decide you're gonna collect. You need to anticipate how much data you're going to have. That involves that that's a fairly simple thing to assess, but it is an important step. You want to be prepared to generate your reports, but as I said, don't let the output, the report, drive your decision making on what you're going to collect. You might think about, you might say, well, this report requires me to include this specific parameter, but there may be other parameters that you can collect to help you assess the quality of that specific parameter. So maybe there's more to it than just focusing on the report or the output. So ultimately, then your choice of platform or how you're going to house the data, how you're going to manage the data, comes down to analyzing how much data you have, how complex is it, and how is it going to be managed and shared. And then the last little quote there, own it. That means you need to take an active role in and not a passive one. You can't just say this is how we're going to manage the data and walk away from it. You need to be actively involved, not only in deciding how the data is going to be collected, but in making sure that things are done correctly. Now, I've talked a lot about Excel maybe not being the best tool for managing large volumes of data. And I have an example here that I came across a while back. And it's very interesting in what it tells us about attempting to manage data with Excel. There are a couple of Harvard economists who set out, to perform an analysis. This isn't stormwater related, but you'll get the idea here. They wanted to study how various types of governments and levels of external debt affected economic growth and inflation under a variety of conditions. So they started collecting data, and they ended up with data for 44 different countries over 200 years, all sorts of different types of governments. And they had basically about 3,700 different cases that they wanted to analyze. So they used Excel to manage all these data and perform their analysis and their calculations and things. And their conclusion from what they studied, they concluded that a public debt level of 90% of GDP or more has a tendency to dampen the potential for growth of the economy. And they published their findings in a book. They wrote a couple of technical journal articles about this, and it became quite a popular analysis. And in fact, several governments in Europe, of European countries, implemented some rather severe austerity measures to try to get their level of public debt down below this 90% level, based on the recommendations in their findings here. Then a reporter came along and said, I'd like to reproduce this. I'd like to see, how this all works and study it more closely. And what this reporter discovered was that 5 out of the 19 countries were omitted from their analysis simply because they misentered the definition of the formula in Excel. So holy cow, they got a big black eye on this, and they said about revising things and whatnot. So basically that serves as kind of an object lesson that I put out there to say, when your data starts getting voluminous or complex, you might want to think about something else other than Excel for managing your data. So the question then becomes, what else? What's a more appropriate way? Well, of course, the database solution is ultimately what everybody will land on in terms of how best to manage large volumes of complex data. And that's because that's what they're there for, okay? So let's talk a little bit about data management systems. There are various different approaches to data management, different types of software, but by a long shot, the relational data model is the most commonly used, both in practice and in commercial software. And I guess those two probably go hand in hand. And there's a lot of popular relational data management solutions out there. The one that just about everybody has access to, pardon the pun, is Microsoft Access. And it can be a pretty good solution for you. It's more hands-on, it's easy to implement at a lower level than some of the more complex things like SQL Server and Oracle. Those tend to require more of an infrastructure. But they're all similar in their focus and how they work, the concepts associated with them. So this is, I would say this is probably what I would consider a best practice answer here. If you have voluminous data, large amount of data, or complex data, a database is almost always the best choice. But that does come with a price you have to pay. Databases are complex, and they're more difficult to conceptualize than a spreadsheet. And I think for that reason, a lot of people don't really understand what the advantages are of using a database system. There's an analogy that a lot of people use. I think it's a little bit of a weak analogy, but I've heard a lot of people say it. If you look at a database, if you just look at a table in the database, it's kind of like a web page with a lot of different links. By that, what we mean is there are data elements in one table that refer to other tables, and those things get chained and so on and so on. So it's like a complex distribution of the data, so it makes it a little bit harder to think about everything in one place. So what that means is when you start to insert data into a database, you may be required to access more than one table in order to save those data. And retrieving data in a meaningful form almost always requires access to multiple tables. That's why the databases do tend to get a little bit complex, and people kind of they get afraid of them. But that's why we say don't be afraid to step out of your comfort zone, because this can be quite powerful, and you may learn that it's a very valuable tool for accomplishing things. Because retrieving data touches a lot of different tables potentially, you may have to become familiar with query language, or at least some sort of framework to build queries, because those things are that's how you're going to get data back out. I'm a mathematician, so those things make sense to me because they're based on set theory, concepts of set theory. So some people get databases, some people don't, but don't be afraid to explore this. So we want to talk now about what it is, what are the advantages to using something like a database? Why is that a better solution? And the first answer to that is because databases have the ability to enforce data integrity. What do we mean by that? What we mean by that is that you can create your database in such a way that it doesn't allow you to enter invalid data. That can be a very critical thing, and we call that referential integrity, and that's probably the most prominent feature of the relational data model, is the ability to enforce referential integrity. There's different ways you can do that. You can have range validation. In other words, you could, if you were putting in, if you were recording water temperature in your database, you could set it, and you use degrees Celsius. You might put in a range validation to say if the entry, so maybe somebody accidentally collected in Fahrenheit. So if the range is, if the entry can't be more than say 35 degrees, because that'd be a flag maybe that they've used the wrong unit. So that would be a range validation. You can also do validation through explicit lists of acceptable values. That's called, these are called lookup tables. There's other names for it, that sort of thing. And the other integrity constraint is the construction of what's called parent-child relationships. What that means is you can define a table to say you can't put anything in this table until it has an entry that corresponds to this other table that's its parent. That would be an example, would be like a sampling event and a table for results for that sampling event. You can set that up so that you can't enter information about results for that sample until there is a record in the samples table to support that. Okay, so there's an example there that we it's a common example. For example, I've developed a lot of water quality databases, and you can set those to reject the results if the test method is not marked as valid for the parameter that's being recorded. Because in your results table, you would record both the results and the parameter, the results, and the test method that was used to determine those results. And so if the test method is not marked as being valid for that parameter, then it would not accept the data. So that's an instant data quality check, and that's part of enforcing referential integrity. Here's a more prominent example. This is a screenshot of a spreadsheet. The column, the first column there is a well ID, and if you see the entry on the bottom row says WG-2007-H. And the question is, what's the meaning of this entry? If you look up a couple of rows up, you'll see that there is a well called WG-2007. So it's got an extra 0 in there, -H. So it's this entry can be ambiguous. Is this a typo and it should be 20007H, or is this a new well? You can't really tell because you don't really have any way of enforcing that as people are entering the data. Technically, I know you can with Excel, but it gets very, very complicated. So that's an example of how you can enforce data integrity constraints in a database. If you were entering this in the database, you would not be allowed to just randomly enter a well ID without previously defining it. So, okay. The second concept that we get to here is called data normalization. What we mean by data normalization is that we want to try to split up our data in such a way that important elements, the primary key elements, are present in one and only one place in their full native form. And the purpose of that, the objective of normalization, is to avoid any sort of errors created when we're inserting, deleting data, and that sort of thing. And I'll show you an example in just a second to kind of explain what we mean by data normalization. But there's a drawback to normalization because it doesn't increase the complexity of your data model, because you're going to have primary elements in tables, in separate tables. So pulling those all together means you're going to have to retrieve data from multiple tables in order to get the information you're after. But there are ways to get around that. Almost all databases support something called a view. And a lot of them have what's called stored procedures. Basically, these are ways you can one time you can define how these data are supposed to come back out, and save that so that you don't have to go through the same iteration every time to enter the same query. But the big advantage that we gain from normalizing our data is that normalized data occupies far less space in the database than unnormalized data. So what that means is you can pack a lot of data into a much smaller space with a normalized data model. And there's different levels of normalization. And these are the three most common. Most people will try to get their data model to what's called third normal form. And there are some technical terms in here, and we won't belabor those. But basically, just understand that there's different levels of normalization, and once you understand what it means to normalize data, you'll be able to make decisions on how far down the normalization process do you want to go. Okay, so here's an example. The table in the upper part of that is a listing of task orders that were issued against a contract. It identifies the project manager for the task order. Each row identifies the capacity of the contract under which it was awarded, and then how much the funding level is for the specific task order. So there's a lot of repeated data in here, okay? Even though these are mostly all codes and short abbreviations, a lot of this data gets repeated. So the top table is not normalized at all, okay? And then down below that are three separate tables that have taken some of the steps to normalize those data. And if you look at that, more closely, you'll see that the essential elements that are repeated in the top one mostly occur in one and only one place in the lower tables. So that's what we mean by normalizing data, is making your data structure such that each table represents a primary set of concept, or one concept that's part of your overall data model. Okay. All right. So once you've started down the road of creating a database and normalizing your data, identifying all the data elements you need, the next thing you need to think about is how many people are going to be accessing it. So we talked about this a little bit earlier, but the database offers some nice functionality here as well, because you can create, for most databases, you can create roles in the database, and you can allow people to have different accounts with different roles. For example, if there are people who need to do analysis on the data, but they only need to get the data out in order to do that, you can give them direct access to the database in a read-only role. That means that they can extract data from the database and they can do the analysis that they're after, but they don't have any permission to make any changes to the data. There are a variety of these different specific roles. You can allow people to enter new data and update, or you can make it so that people can not enter new data, but they can update data. All sorts of roles. So you can basically craft access to the data specific to your different sets of users. Okay. Another thing about databases is they are inherently multi-user by nature. They have built-in capabilities to control the insertion and update of data, that sort of thing, so that you can have multiple people accessing even the same table at the same time. And there's no check-in, check-out required, like if you're doing like an Excel spreadsheet or a Word document or anything like that. So you can have multiple people accessing the data all at once. If those people are all within your organization, you can accomplish. I'm sorry.
Shit.
Is that a question? I'm sorry. Is that? Okay, maybe not. Okay. If all the people that need access to the data are within your organization, then you might something as simple as a very simple desktop interface to the data might be sufficient. And you are going to want to do some kind of interface to a database because of the complexities that we talked about. You don't want to just have people point people to the database, because unless they understand how databases work, it can be a little intimidating. So you're going to want some sort of way to present the data to them. But so if all the people that need access to data are within your organization, a desktop interface is probably a good solution because it's the simpler solution. But if you need to share data with other organizations, you might have to look a little bit beyond that. You might have to, you can either set it up so that they can access the desktop interface that you have within your organization, or you might consider actually developing a web interface if you have a lot of people that need to get access and you don't necessarily know who they are, or don't want to have to control who has access. Okay. Another advantage that we get with databases is it gets us into the GIS world much easier. Almost all GIS data that you will consume, we talk about consuming web services thing. Almost all the data that you consume is coming from a database. That's because databases tend to be an inherent feature, an inherent part of GIS systems. Almost all GIS systems are built with databases in mind. And you can build custom queries in the database that will make it easier to retrieve data in a GIS environment. You can filter things within the GIS, that sort of thing. But the big advantage here is that the GIS can offer a very nice map-based interface to accessing the data in your database. There's also, if you have to conform with other standards, SDS-FIE is a DoD standard. So I've done a lot of work with DoD clients. So there are standards for how you construct your database, and if you want to be compliant with SDS-FIE, so it does give you a way to not have to reinvent the wheel if you're in that vein. Okay. SDS-FIE is built. There are a lot of databases out there that are based on sharing data. These tend to be government-sponsored sites and databases and things, but they're intended to share data across multiple users. One of the more popular ones that I've dealt with a lot is EPA's Water Quality Exchange, which is a data system for sharing water quality data. And if you collect data and EPA gives you money to support the collection of those water quality data, then most of the times you are required to submit your data back to WQX. And that becomes a much easier lift if your data is already in a database. Okay, it can be really tricky to try to post data to some of these external repositories if you're trying to wrestle spreadsheets into the proper form. Okay, so at this point we can kind of circle back on database design and talk about what are some of the best practices associated with database design. This is assuming that you have decided that you need a more robust tool to manage your data. So data, and you want to go the database route. So the choice of the specific platform, we've talked about this already, but here we're actually putting it down as a best practice. The volume of data and the complexity of the data, the users who need access to your data and what their experience is with interacting with the data, and any potential external users. Those will help you define and identify an appropriate database management system for the platform. When you start creating the database, you definitely want to normalize the data because, like I said, the objective of normalization is to try to reduce the potential for errors in the data, and that's always a good thing. But I would say, don't go nuts. Don't think you have to over normalize and normalize it to death. You can get to a reasonable stopping point fairly quickly with data normalization and be reasonably sure that your data will be adequately maintainable. And you want to identify and define those integrity constraints where they're appropriate. Things like valid value lists. One of the common practices, one of the things I do in almost every database I design is to represent elements as coded values. An example of that would be, for example, a list of parameters. especially if you're talking about chemical parameters. They can have very complex names. So you don't want those names to have to match. You don't want to have people have to be so careful in picking those names, because some of them can be quite difficult. So when you normalize the data, you put the name in one place, and you have a code that represents that parameter, and then you impose those data integrity constraints such that when you start to enter results, those the code for a parameter has to be present before you can actually insert the data. Okay. All right. So at this point, you might be saying, "Oh my gosh, do I really want to get into this? Is it worth the effort?" Well, the good news is you don't necessarily have to reinvent the wheel. And the reason you don't have to do that is because there are a lot of databases out there that people have already developed and are using. So, if you decide you need a database for managing your data, don't immediately jump to the conclusion that you're going to have to create something from scratch. Look around and see what other organizations similar to yours are doing, how they're collecting data, what they're using to manage the data. There may be some databases inside your organization that you're not aware of. Look inside and outside to try to find representative examples that may be appropriate. And even if you think it's not, well, this is for a different type of data, a different category of data. This is not exactly what I'm after. It may be very close. For example, if you want to focus specifically on water discharged from some sort of industrial process, but the only thing you can find is something that manages groundwater data, chances are that you can adapt that data model fairly easily. Make a few tweaks in that data model and make it acceptable to what you need. So you don't have to, even if it's not perfect for what you're doing, it may be close enough that you can start there and tweak it as needed. But the key element here is don't gloss over reviewing your data model, and also understanding you're going to definitely need to understand the data model that's implemented in any sort of solution that you propose to use. Okay, so once you've got your database defined and everything, you need tools for interacting with the data in order to make sense of the data coming out. Most database management systems have built-in options for creating, we talked about views of data. A view is we talked, terminology, I don't want to bog you down with terminology. Everybody understands, I think, probably what we mean when we say a table. A table has some basic data in it, but we talked about tables being related by having values that point to records in other tables. But the table is inherent in the database, but there's something called a view that is essentially a pseudo table, we'll call it. It's a construct that says take this data element from this table and this data element from this other table and put them all together and it's not actually a table in the classic sense, because it's not actually stored anywhere. It's constructed as need be, but views can be very helpful for rounding up data and making it more presentable and understandable. Reports, almost all database management systems have ways to define reports that you can click a button and get out. A lot of them have forms capabilities built in. There are external forms software that works very well with all sorts of databases. Some of them are database management system specific, but I'm sure if you settle on a database management system, you can find form software that will interact with it appropriately. So you can construct forms without having to do any programming, that sort of thing, to get your data in. If you have users who are going to be remotely entering data, you might consider web templates, which are also pretty readily available. Ultimately, though, a lot of times you're going to want to settle on actually a complete user interface. And a lot of times it's more efficient, and I just throw this out because this is my experience, a lot of times it's more efficient to separate the user interface from the database. That way you can, if something happens and you need to move to a different database backbone, you can salvage your existing interface pretty easily. So these interfaces that you create can have lots and lots of features and functions, and do things like not only as you know, there's forms, there's examples of forms on this screen that show you forms for collecting data, forms for reporting data, and forms for importing data, as well as some custom graphical outputs. These are all from a single data management system that I've been developing for quite some time. These are all built-in capabilities, so you don't have to go outside. You don't have to rely on other tools for getting your data in or doing some analysis. Okay. So with that in mind, okay, so hopefully by now you see the advantages of using a database rather than trying to rely on something as rudimentary as Excel. So where do you go to get help in making these decisions and figuring out where to go from here? Well, you know, look internally. There may be coworkers and project managers and other people within your organization that have experience with databases that can help you. You can go outside to organizations that specialize in data management, that sort of thing. You can also rely on reference materials as you typically would. And there's a lot of internet resources out there about databases, about how to build databases and how to use databases and everything. My experience is there's a lot of bad information. Well, and I shouldn't say bad information. Typically, what I find is that there's a lot of outdated information out there on the web about databases. You know, it may have been true at one point. So use internet resources with caution, but they can be very helpful to you. Okay. All right. So now we're ready for part 2 of database design best practices. Okay. Kind of summarizing the last few things we've talked about. Get examples from similar efforts and similar types of data. Don't think you have to reinvent the wheel and start from scratch. In most cases, I think you can pretty easily find examples that you can build on, or that you may be able to very quickly adapt, or maybe able to use as they are. I would caution you, try to make sure that you only work with platforms that are supported by your IT department, because especially for some of the more complex things like SQL Server and Oracle, that's a heavy lift to do by yourself. Access you can get away with. You can get away with Access just on your desktop if you work hard. Well, you don't have to work that hard, as long as you exercise a little caution and understand what you're doing and get some help there. But beyond those, don't try to go too far outside the bounds of things that are supported by your IT department, because you may have to come to them to get help with some of the more mundane aspects of getting the database software installed and running and everything. And then don't be afraid to reach out for help. All right, so we're wrapping up this discussion now. So in conclusion, what I want to say, what I hope you've thought about to this point is, I hope you can take away from this. These are best practices associated with managing the data that you're collecting. So the last question we want to ask is, how do I know if I'm on the right path? How do I know if I'm doing these things properly and I'm taking care of things the way I need to be doing? Am I adequately protecting my resources that I have gathered, my data that I've gathered, that sort of thing. So there are ways that you can go about evaluating your current situation to find out, am I doing this right? That sort of thing. First of all, do you have a data management plan? Are you adhering to that data management plan? Have you had any problems with the data you've collected, either getting the data or not being able to, or not having the data that you need to do certain analyses, that sort of thing? And what steps can I take to improve my data management approach? And you can do these, you can answer these questions a couple different ways. You can do a self-evaluation. That can be a very good first step, even if it's not the only step you take, because it helps to ask these questions of yourself first to make sure that you thought through the process more fully. You can request evaluation by others within your organization. I would suggest that you're going to get the best results from these evaluations if you make sure that you you request these evaluations from somebody who has a good, strong background in data management. But there are likely people in your organization that do have that experience, and they can help you assess your situation. And then you can also reach outside your organization. If you have if there are other similar organizations that you have a good relationship with that do the similar things that you do, you can ask them to evaluate you. And then you can also reach out if there's a contractor that you have that you trust, that you work with a lot, that has some expertise in-house in proper approaches to data management. You can ask them to do an assessment. So those are ways that you can go about assessing where you stand with regard to establishing these best practices or following these best practices. Okay, that's pretty much it. I do have at the end of the presentation, and I guess I'll talk to Charlene. I can make these slides available for distribution if that's something. So there's some references there for some things you can look up about data management principles and that sort of thing. But with that, I think we are concluded. So I'm going to open it up to questions or thing, and then if you have anything, if there's something you want to ask and you're not comfortable asking it in this environment, jot down my direct phone number there. Give me a call or send me an email, and I'll be glad to try to offer any additional guidance that might help in analyzing this situation. So with that, I am going to stop sharing my screen and turn it back over to Charlene for closing comments, and open it up to questions, by the way. If anybody has any questions they want to pose now, please don't hesitate to jump in, and we'll go from there. Thank you.
Anyone have any questions before we close out? Nope. Anybody have anything to add at all? Okay, I wanted to make sure. I will go ahead and thank you so much, Gerald. That was really fantastic. You're a really good speaker. I remember that from the conference as well. So I really appreciate
thank you.
That.
And I will say, I meant to mention this earlier too. Charlene reminded me that I gave a presentation at last year's TNSA conference about using some software that is free software. It's public domain software, so anybody can use it for free, but it has been used effectively for managing specifically stormwater data in the past. So those of you, I mean that's the focus of this organization. For those of you who are directly involved in managing stormwater data, I gave a presentation last year. I'll be glad I can review that with you if you're interested in taking a closer look at that in case you missed it last year, or if you, I mean, we've all slept since then, so we've probably forgotten everything that was said. If you want to revisit that, you can reach out to me as well. Sorry.
And most likely I still have your presentation, on my computer that I can send to folks as well. But if you would like to send that over, I send out certificates for everyone, and I can send all your contact information along with the presentation to get that out to everybody in the next day or two.
Okay.
And I've already sent you guys out the information about the next TNSA talk coming up, but I'm going to go and share my screen really quick. While we were talking, I did have someone agree to another TNSA talk. We don't really have a whole lot coming up for, is it showing up there? I have to take us a second before I can. Okay. Okay. We don't really have a whole lot of TNSA talks coming up. We have one next Thursday with Don Green, so we're excited about that. And then Steve Casey has agreed to do one. He's not decided on his topic yet. I know Paul Davis was talking about trying to pick a topic and having one as well. And then Vina Jones with the TDEC SRF program has just agreed to do a talk for everyone as well. We do have regional meetings in the first couple of weeks. Oh, I didn't put the date for September. Sorry about that. I believe that's the 16th. I did not finish filling that out. I was in the process of emailing with her while we were all talking. So anyway, but that will be September 16th, and I'll get all of that updated on the website. But we do have meetings for the first couple of weeks for regional meetings in September, and I believe those will be on Zoom. We have not determined what will happen for conference yet. I have a feeling with everything going on, we may most likely may not have that in person, but we will decide that at the August 20th board meeting we have coming up. But these are our TNSA talks coming up. If you know anyone who would be able or wanting to host a TNSA talk, please let me know. If you would like a specific topic covered, please let me know, and I can look for someone to also work on that. I think that's all I have to cover. Just don't forget to check your emails about the TNSA talks coming up. We also have that on the website, and we also put webinars on the website, and we have a little thing for webinars. I try to limit emails as much as possible to members, just because I just don't like getting a lot of emails. So I also added that to the website. And if no one has anything else, I guess we'll say goodbye. And thank you so much, Gerald. And thank you all for attending today. And I hope you have a good rest of your week and have a great weekend and stay healthy. Thank you.